Okay, so let's do some projectile questions. Let's do the question 2. Alright, here we go. Okay, so projectile P is projected thing. So by the way, projectile questions, your A is always equal to minus 0.8 because it's just being flung in the air, okay? So again, we're going to do the T equals 0, V equals, what am I talking about? 3, 4. And by the way, it's the same thing. This is projectiles is AVR. Everything to do with kinematics is AVR. So we want the acceleration. We want to know the TVR at 0, and so we just build the AVR, and then we're just going to use our logic. So okay, at a point 20 meters above the ground, so that means it's 0, 20. Yeah, and by the way, we could have drawn like a little diagram as well, so you know it's at 0, 20, and we could have done that T equals 0, and we would have done the exact same thing. So you can either do it like that, or you can do a diagram. It doesn't really matter. Let's build our AVR. That's going to be 3 minus 9.8 T plus 4 R equals 3T minus 4.9. How many times have we seen that number? Plus 4T plus 20. Okay, so find the speed of the particles after 2 seconds. You're just putting T equals 2 into here. So, minus 9.8 times 2, add 4. It's minus 15.6. 2 squared plus 15.6 squared. Technical minus if you want to do that. Plus 4. The answer is 15.73. There you go, 15.73 meters per second. You don't even have to write meters per second. Okay, find the greatest height of P. So think about it. So that's been flung like that, or it goes like that. We want this thing here, okay? So let's kind of see what we know. We don't know what the time is. Do we know the velocity? Well, we don't know the velocity where it's moving, but when it's maxed out, it's 0 here and goes the greatest height. R, we have no idea about R, you know, but we want that. Does that make sense? So obviously, can you see what we do here is we use this to find the T, and we're going to put the T and move it into there. So if I put minus 98 T plus 4 equals 0, solve that. I'm just going to do that in one swoop. T equals 0.4082. Don't round too much, by the way. And then you can just put that into that bottom bit. Yep. So the answer you should get is 20.82. 20.82 meters. And by the way, I just put this T into this line. Okay. So hopefully that makes sense. Alright, let's rub some of this stuff out. Find the horizontal distance by P before it hits the ground. Okay, so when it hits the ground, we're looking at this point here. Let's see what we know. Do we know the T here? No idea. Do we know the velocity? Nah, we have no clue about the velocity anyway. Do we know anything about the R? Well, we want that, but we know that's 0 because it's hit the floor. Well, what this is involving, this has got to mean that we make this equal to 0, find the T and put it into here, okay? So minus 4.9 T squared plus 4T plus 20 equals 0. Calculate a job. And remember, you've got to put both the T's, even though it's obviously not going to be the negative one. Yeah, and just kind of like maybe underline it or show that as that, but show clearly you have got that number. And then can you see, so what we've just done there, we've just unlocked, we know that this one is, this happened at 2.469. Remember, time is what makes everything happen. Put it in there, times it by 3 basically, and you'll get your answer. 2.469. Yeah, the answer for this one is 7.407 meters. Again, I don't think the units are important. Is that what they got as well? Yep. See, look at this. T cannot be negative. Can you see that? They actually want you to say that. The answer is 7.4. Yeah, good. Okay, let's go into your next question. Yeah, well, let me just do a new canvas. Oh, come on. Okay, what's the other question? 3. Okay. Okay, this looks a bit more interesting. A equals 0. minus 9.8 because the particle is projected, it's projectile from ground with velocity. Okay, this is going to be interesting. Okay, so it's flung, yeah, it's moving like this. Okay, its initial velocity is like this, so it's theta, except we know that's 25. So remember, we need to know the TVR here, so we need to know it in I and J form. So can you know, the best we can say is this 25. Sorry, that's going to be cos, isn't it? Cos theta at the bottom and 25 sine theta. That's all we can do, you know. So this is 25 cos theta, 25 sine theta. Okay, that's our VR0 thing. It lands after 5 seconds, so that's going to be useful as well. And, you know, we might as well start off by calling it 0, 0. So basically what we're just doing is like it starts here and goes like that, okay? So that TVR here is it's just for like that point bit here. Okay, so let's build our AVR as best as we can. 25 cos theta minus 9.8 t plus 25 sine theta r equals 25 t cos theta, that's probably the best place to put it, minus 4.9 t squared plus 25 t sine theta. Make sure you don't put the t after that, because then it looks like you're causing the theta t. Okay, so 25 t cos theta, that's the best way. Okay, now let's see. So we've got to find the value of theta. It just means we need to have an equation where we can solve theta. Well, here's what you do know. This is pretty important. P lands after 5 seconds, okay? So let's have a look at that. That's this point here. Okay, so t equals 5. Let's see. Do we know anything about the velocity? We have absolutely no idea what the speed is. No clue, no clue. Do you know anything about how far it is? Absolutely not. But we do know that's 0. Okay, we do know that's 0. So here you go. Let's put t equals 5 into here and make it equal to 0. So minus 4.95 squared plus 25, 5 sine theta equals 0. And this is going to become pretty nice pretty quick. Times 25. This gives me minus 122.5 plus 125 sine theta equals 0. So you're going to get sine theta equals 122.5 over 125, which is actually equal to 0.98. Inverse sine it. Let's see what we get. Whoops, no. Fuck. 78.52. Excellent. Right, so degrees. Okay, now don't forget we should update all of this stuff here in our AVRs. So let's update our AVR. Let's actually do that. Okay, so firstly we can actually get the exact values for this V. So let's actually do 25 cos 75.52. So that's actually 4.97. No, got it right or wrong. And this one is going to be like 25 on the dot, okay? So this one's a 4.97, which makes me think, have I just done the first one wrong? Cos, no, I haven't. It is just what it is. Okay, plus 25, so that'll be plus 25t, and that's just like 4.97. T. Yeah, I don't know, I just had a bit of a mind blank there. So what we're trying to find, we're just trying to find that one. Find the horizontal distance, travel by p before it lands on the ground. So we just want that one. So we're just going to put t equals 5 into here. So it should just be 4.97 times 5, 24.85. Let me make sure no errors. Yeah, okay, 24.87, I got 85. Yeah, basically correct. That's question 2. Hopefully that feels quite nice, you know? It's just understanding this AVR, you know? Like, you'll be shocked by just how AVR just stays the same. But you got to see a few questions, make sure you kind of feel comfortable with it. Let's get to question 6. Oh, wow, yeah, that one looks, that one looks absolutely horrible. And it looks horrible, by the way, off first glance. Now, just remember, we're just going to do the exact same thing every single time. All right, let me just quickly pause it as well. Go grab some water. Okay, so this one's going to start exactly the same, all right? So we know it's a projectile, so A equals minus 9.8. So we need to kind of get the initial velocity. So the initial velocity, here's what it's saying. It goes at an angle of theta, and it's u. So can you see this is going to be u sine theta, u cos theta, and we can't really do much better than that. So at t equals 0, because we're always going to build our AVR, this is u cos theta, u sine theta. R equals 0, 0, because we've got point 0. Okay, so let's build our AVR. So we get u cos theta minus 9.8t plus u sine theta. Integrate again, get u t cos theta minus 4.9t squared plus ut sine theta. Okay, now we've got to show, now by the way, here's what it's saying. It goes when p has horizontal distance x, so they're calling this another way to call this like x and y. Does that make sense? Has moved horizontal distance x and its height above always y. Okay, so can you see we've kind of got x equals ut cos theta, and we know that y equals minus 4.9t squared plus ut sine theta. Okay, it wants you to show that. Now, can you see this is sort of kind of like what Cartesian equations is, where you've got like, you know, you've got x and y with defined in terms of t, then you've got to rearrange one and sub it into the other, so you get an equation where the t's go away. So I mean, cos theta is absolutely fine, u's are fine. It doesn't want t. So really, this is just a case of making using one of them to make t the subject and sub it into the t's from the rest. Now, obviously, the easiest place to get t is going to be here. So if I rearrange it, I get x over u cos theta. And now let's sub it into the bottom one. So y is going to equal minus, and what they want g's, don't they, in this? Okay, they want g. They want in terms of g. So by the way, can you see minus 4.9 is g over 2? Hopefully that makes sense, yeah? And then you're timesing, then you're bringing t squared into this. So we're going to have x over u cos theta all squared plus u x over u cos theta sine theta. And now remember, you should have this, make sure you write this on the side or something, because you always want to know what you're trying to get towards. Yeah, okay, so let me and again, I'm thinking I should kind of write it here. Let me write it here so we actually know what we're kind of going towards, especially as I scroll this screen, x tan theta they want, plus gx squared over 2u squared cos squared theta. Now let's just have a little look. Okay, so this is our kind of aim of what we're trying to go to. So you can kind of see, just by looking at it, can you see that g's lining up? This is going to be an x squared. We're going to get a u squared cos squared there over 2. That's looking good. Over here, we want this to just become x tan theta. Well, those u's are going to cancel. We've got sine over cos. It's looking good. Now let's just kind of like clean it up. Wait, was there a positive one? Yeah, that should be negative, which is good. That's what we wanted. Okay, so now if we just kind of multiply this out, can you see we get g over 2 times x squared over u squared cos squared theta. That's excellent. With this one, if we just kind of put this all together, we're going to get x u sine theta over u cos theta. So you can see those are going to cancel. That's going to turn into tan x. And this is going to very quickly become exactly what we're looking for. So you see, it's actually not too bad, hopefully. Voila. Right? And then what do we say? So we're given that, so let me kind of just bring this to the side here. Then it goes, we're given that theta equals 45. So let's, first things first, let's, when x equals 6, y equals 2. So if we can start updating some of this stuff here and all of that as well. If we just kind of clean that up. Let me just do that. So let's update our, so we know that this will equal 6 to, see that? Excuse me. It's my bad. No, what am I thinking about? Oh yeah, of course, it's a show that question. So let's obviously use this. That's quite a hint. So telling us y equals 2. So let's replace it exactly. So 2 equals 6 tan 45 minus 9.8 6 squared over 2u squared cos 45 squared. Okay? And what's the aim of our question? Find the speed of p. So we need to find t, don't we? We need to find t when all of this occurs. So what am I kind of thinking here? Okay, so we know that. We also know that 6 has to equal u t cos 45. So let's get very clear on what we want. 2 equals minus 4.9 t squared plus ut sine 45. Okay, so here's what we can do. Can you see, by using this, we can kind of get that we're going to get u. And once we have u, remember, we need to find, we can find t here. So we're going to find u. This is a bit messy, but hopefully it makes sense. We'll find u. Oh God, let me say that again in a smarter way. Oh, why rob that? Okay, so if I update that. Okay, so we're looking at the point. Oh God. Okay, we're trying to find the speed. So obviously we're going to need to know what the velocity is at this given point when x equals 6. So let's kind of think about it like this. There's a certain point, whenever this thing kind of goes, we don't know what the t is. We don't know what the velocity is. That's really what we got to find. But we know that the r is 6 and 2. There you go. That makes so much more sense. Now, so remember, if we're going to find the velocity, we need to find t. We have to find t somehow. But this is actually quite a difficult kind of task because we've got so many unknowns. So the smartest thing to do in this situation is just start to put down anything which you know. So let me just kind of rub that out. So we know that 6 is going to equal ut cos 45 because remember it gave us that theta equals 45. and we know that the bottom line of r is going to equal 2, so we can put that equal to 2. Yeah, basically. And we might as well update this show that there must be a reason for that, right? Well, can you see when you do that, you actually, the only unknown in there is u. We can actually use this to find u. Because by the way, if I just, I'm doing this in such a stupid order. But at the end of the day, okay, blank your mind. I need to blank mine as well. All right, the question says we want to find the speed of p at this given point. So we need to find that. So if we look at velocity, to find that we're going to need to know 3 things here, okay? We need u, we need t, and we need theta. We got theta. That's 45. Okay, that's good. We've been given that. So and that's why I've updated here and put theta 45 into here as well. U we need to find, and we need to find what t is. To find u, we're going to need an equation which has u only. To find t, we're going to need an equation that has t only. This is the best we have. So let's use this equation to find u, because that's the only thing I can see where I'm going to find u. Yeah, that's better. Alright, so let's start putting stuff in. So 6 tan 45 is 6. Okay, minus 9.8 times 6 squared, which is 36. So I get 352.8. Let's do 2 times, what's cos 45, that's root things. If I square it, I get 0.5 times 2. So all of that bottom thing actually becomes u squared. So if I take that away, I get minus 4 equals minus 352.8 over u squared. Let's times by u squared, so I've got minus 4 u squared equals minus 352.8. Might as well have got rid of those negatives, to be honest. Come on. Yeah, u squared is going to equal 352.8 divided by 4, so 88.2. U equals 9.39. Alright, excellent. We've got one more, so this is 9.39. Now we need t, because remember we're trying to find the velocity at this point. Let's use, this one looks pretty nice. So let's go for this. U equals, we know that's 9.39. We want t, and it's going to be times, what's cos 45? I think it's, no, yeah. Root 2 over 2. I'm just going to put the number in, 0.7071. Okay, so what's that? 6 equals times 9.39. 6.64 t. So t equals 6 over 6.64, which equals, okay, 0.904. Excellent. Oh, God, that's a mess. Okay, I'm just going to rub some stuff to make some space. We actually now can find the v, so let's put it in. V is going to equal 9.39 cos 45 minus 9.8, 0.904 plus 9.39 sine 45. Okay, calculator jobs, let's do that. 9.39 cos 45. So the top one becomes 6.64. Let's do the bottom one, minus 9.8, 0.904 plus 9.39 sine 45. So I've got minus 2.22. Yep, so that's the velocity at this point. So just for speed, what do I need to do? I just need to do all that good stuff. Technically that, I guess, it doesn't really matter. Yeah, the answer is like 7, more or less on the dot, 0.00111. Okay, 7 meters per second. Oh, God. You know what? I just went all around trying to kind of explain that second bit, which is a complete mess. But did you see it wasn't actually bad? The path is there. The path is really there. So just to kind of like show you again here, yeah? And recap that one. Honestly, this thing is moving. Ignore my bitching and whining. Okay, so you know, we have the AVR, and we're basically, you know, it's telling us, you know, in our path, there's a point. It tells us what the position vector is. So you know, if we do TVR, so it's still staying to the exact same thing. So we do TVR. We know we're talking about the point where it's 6.2, and we're trying to find the speed. So we know the velocity. No, we don't know it's 0. My bad. We also don't know the time. So when we look at that, we're like, we need to be able to fill this in. And what we normally it's just t that we need, but in here we need u, t, and theta, which were actually given in the question. Okay, so we need to find u and t. So it's actually a bit more difficult than normal. The whole point of this show that thing is it gives us a way to find u. So we kind of found that's 9.39, and then because we knew that that was 6. It was very easy to rearrange actually in the end. To find t as well, and then we could plug it in and we could do the square root stuff. Whew.